Hello, it's your boy Andy, here to teach you some more about the exam unit 3. So, what I'd like to talk to you about this lesson is dependent and independent variables and controls. We touched a little bit on controls last lesson with validity. I'd like to talk to you about graphs, what should be included on graphs, and if we've got time, which we probably will, talk about percentage error. So 3 things. And then if we get through them quick enough, then you can go on your lunch or whatever you have after this. Okay, new page or same page. You can use a different pen if you want. Write on 2 words. Not words. My brain's really struggling at the moment. Write down the 2 things: dependent variable and independent variable. Okay. Now imagine you have an experiment, and this experiment is different weights of people, so how much they weigh, and how much coffee they drink in the morning for those coffee drinkers. They're your 2 variables. One of them is the dependent, and one of them is the independent. Now, there's a lot of ways you can think about this, but I feel like, myself included, because this took me a little while to get my head around, the way that I like to think about it is the dependent variable depends on something, and the independent variable is the other one. So, write down your little experiment and the 2 variables you have: the weight of the individual and how much coffee that they drink. And you can write it both ways. Write it the weight of the individual, how much they weigh, depends on how much coffee they drink. Or write it the other way: how much coffee they drink will depend on how heavy they are or how much they weigh. Which one do you think makes more sense? Is the reason that people weigh a lot because they drink a lot of coffee, or do they drink a lot of coffee because they weigh a lot? Of course, there's lots of variables that could mean different things, but generally speaking, the one that makes more sense is that the amount of coffee they drink depends on how much they weigh. So how much coffee they drink is the dependent variable. The dependent variable depends on something else. The independent variable is the other one. And the reason I just say it's the other one is because you can fall into a lot of pitfall traps with the independent variable. And it's much easier just to think of the dependent variable is the one that depends on something, and the independent is the other one. The independent is normally the one that you have a little control over in some experiments. So, for example, if you were trying to find out how many people commute to London on each given day of the week, the amount of people will depend on which day of the week it is, rather than the day of the week depending on how many people there are. Okay, hopefully that makes a little bit of sense. Okay, now you have the control variables. Now the control variables are everything that you want to try to keep the same. And you can be as creative as you want with this. So for the weight and the coffee, you want to probably keep the coffee brand the same. You want to maybe keep the height of the individual the same. You might want to keep the age the same. You might want to keep the day of the week and the time that they drink it the same. Oh. You might want to keep the nationality of the people the same. Lots of different things you could keep the same. Nice. Okay. Bear with me 1 second. Let's find some variable examples. That didn't seem to work. I'll have to download this file. My apologies. That's better. Wonderful. Okay. I've got some for you here. I would like you to write down what the investigation is, the independent variable in this investigation, the dependent variable in this investigation, and any controls that you'd like to keep the same. I would like you to do this first one. How does the weight on the edge of the spring affect its stretching? I would like you to do this second one. This 1, 2, 3. The fourth one, does temperature affect how quickly sugar dissolves in tea? And this one, which is the better detergent, Surf or Ariel, which are two different brands of soap. So this one, how does the weight of the end of spring affect its stretching? Does temperature affect how quickly sugar dissolves in tea? And which is the better detergent, Surf or Ariel? I'll give you about 10 minutes for that. And you could be as silly and as creative as you want for the control variables. In fact, whilst you're doing that, I don't mean to be rude, but I need to go to the toilet quickly. And I'm back. Nice. So, how does the weight on the end of the string affect its stretching? So, the two variables are the weight and the stretching. So, you can write it out both ways. Does the weight depend on how much it stretches, or does how much it stretched depend on the weight? Whichever one makes more sense, you can find out the dependent variable. So hopefully the amount it stretches depends on how much weight you put. So the dependent variable will be the stretching. The independent will be the other one. So for this one, it will be the weight. It's the one you have a bit more control over. Speaking of controls, what kind of things would you want to keep the same? Well, you'd probably want to keep the... Oh, spring, not string. Oh dear, my dyslexia go into overdrive there. You'd want to keep the spring the same. You'd probably want to keep the types of weights that you use for each different experiment similar. You will probably want to make sure that you're doing it not on the moon, because that might affect the stretching with gravity. You probably want to keep it in an environment with not much wind blowing, which could make it swing. You need to make sure that there isn't some spring bandit that runs into your experiment classroom or lab and knocks your spring. Hopefully you can come up with some other things that you'd like to control. Nice. Okay. Does temperature affect how quickly sugar dissolves in tea? The two variables there would be temperature and time it takes for sugar to dissolve. So, does the temperature depend on how long it takes the sugar to dissolve, or does the sugar dissolving depend on the temperature? Which one makes more sense? Hopefully the time it takes sugar to dissolve depends on the temperature, so that will be your dependent variable, how quickly sugar dissolves, time it takes. Your independent will be the other one, temperature in this case. What would you like to control in this one? You'd want to keep the type of sugar the same. You'd probably want to use water from the same water source. You'd probably want to keep room temperature the same, because if you do it in the summer heat of Saudi Arabia, that's going to change your result than if you did it in the Arctic. So make sure you do it in the same place. Make sure that you use a similar cup to dissolve the sugar in. So for example, don't have one cup made out of sugar, because that might affect it. Keep that under control. If you're going to stir it, make sure you do a very similar amount of stirring. Make sure that the weight of sugar is the same. Hopefully you can think of a few more. Nice. And this one's slightly trickier, which is the... Sorry, got another sneeze. Which is the better detergent, surf or Ariel? So this one needed a bit of creativity from your side. What do you mean by better? How could you measure that? Some of you might have been confused by this, so I'll give you a bit of time. Could it be... So you can work out the independent variable. The independent variable here would be the surf or the area, the type of soap. But you have to come up with the dependent variable. So could it be the amount of dirt removed? Could it be the amount of bacteria still there? Could it be cost? Could it be availability in your country? Could be any of these things. See if you can come up with a new one, or a different one, or use one of my examples. Doesn't really matter. Okay, so that would be the dependent variable, because all of those things would depend on the brand. The independent variable will be the brand, so for area. Things you want to keep the same: the amount of washing powder that you use. You'd want to keep the washing machine probably the same. You want to use similar stains of dirt, potentially. The same currency, if you're analysing the price. That kind of thing. Nice. Hopefully you've got a little bit of an idea on the independent and dependent variables and their controls. Let's go backwards a little bit. Back to validity. So validity is how you keep all these control variables under control. Essentially. So if you didn't manage to keep under control the fact that you used the same cup and one of the cup was made out of sugar, suddenly your result would no longer be valid. Or if someone replaces the sugar with a similar looking powder, it's not actually sugar, such as salt. That would invalidate your results. Your results would no longer be valid. Lovely. Go back to paint. Okay. I would like for you to draw this graph for me. Thereabout. Close enough. Doesn't really matter. Draw something similar to that graph. Cough, cough. Ugh. Oh. It's going to be very interesting to hear what my voice is going to sound like tomorrow, because it's normally the morning after it drops by an octave or two. It gets really interesting. So I needed to do all of my recording today, which is Sunday, because tomorrow morning my voice could be very interesting. It sometimes goes about another octave lower than this, so very deep. Happens if I'm ill, if I've been up too late, if I've been shouting, that sort of thing. So once you've drawn that for me, that graph, I'd like you to make a list and check it twice of all the things you think are missing from that graph. There are quite a few things. I'm looking forward to night number 3 with no sleep. Yay. You can, of course, discuss within yourselves Team effort. Team effort. What do you think is missing from there? Give you about 5 minutes. Oh dear, I'm trying to mute myself just before I cough. Alright. Things that could be missing. Big one. The title of the experiment. What on earth is this graph even telling you about? Another one. Units. Time. Is it measured in seconds? Is it measured in minutes? What is it measured in? Years, maybe? Temperature. Let's go for degrees C. Imagine this was just flipped, whatever. You'd probably need some numbers. And make sure these are appropriately spaced, probably with some sort of grid system. Using graph paper is good, but if you don't, make sure you've got a grid system. Time in seconds. Imagine I put some numbers there as well. Nice. You might want a line of best fit. What if you did this experiment on Tuesday instead of Monday, which is today when you're hopefully listening to this? And the Tuesday bits you put triangles instead. I the x's. Probably need another line of best fit. How would you be able to tell what the differences between the x's and the triangles are? You might need a little key or a legend. Monday, Tuesday. Nice. You might want little arrows showing the direction you want to go. Can you think of anything else? I might have missed out something. So if you can, shout it out to the class, and through the wonderful power of democracy, class can decide whether they think that you should have it on the graph or not. So use the next 30 seconds to shout out any ones that you think I might have missed off. You may also, although not necessary, want to put sort of your tabulated data underneath. It's good to have the numerical values as well as the table. Ooh, here's one that I forgot. You might want to add your standard deviations. You can add this very easily on Excel. In case you're working out the standard deviations, you may want to do that. No error bars. Nice. Can't think of too much more. Get rid of this. Okay. I'd like to talk to you now about percentage error. It's another calculation you're just going to have to learn. Let me get it up. Bear with me 1 second. No, I'll just write it then. Okay. Percentage error equals percentage error is the absolute measurement divided by the actual measurement and that is times by 100. So you've got a ratio times by 100 and you get a percentage. Now, the absolute measurement is half of the smallest increment that you can measure. So, imagine a ruler, and you've got millimeters here, or imagine they're millimeters. Now, the smallest measurement you can make is a millimeter on this particular measuring device, but you're able to kind of tell let me use blue for this. If it was bang on the line, you'd be able to tell. If it was slightly above, in between the two, you'd also be able to tell. You can't really tell if it's like 0.8 in between, but you can kind of tell if it's not on the line. You can tell if it's sort of in the middle. So the absolute measurement is half of the smallest increment you can do, because you can kind of tell if it's in between two of the measurements. So for example, this one, let's use the ruler in millimeters, it will be in millimeters. Your actual measurement will be the measurement that you read. So imagine this here, this blue line is your measurement. And it is 200 millimeters. Your actual measurement will be 200. Your absolute measurement will be 0.5, because it's half of your smallest increment. They all need to be measured in the same way. So it'll be 0.5 divided by 200 times 100 gives you your percentage error. I'd like for you to calculate the percentage error for the following. If the absolute measurement is let's just do 3. And the measurement you make is 200 millimeters, 600 millimeters, and 1 meter. Now, be careful with this last one. They all need to be in the same units. So you need to either convert centimeters into meters or meters into centimeters. Could you work the percentage error out for each of those 3? I'm going to calculate them myself. Please use your phones if you haven't got a calculator. Okay, for the first one, you should have got about 0.25%. For the second one, you should have got about 0.166 or 0.17%. And for the third one, hopefully you've either converted the centimeters into meters, so that'll be 0.01 meters and 1 meter, or you've converted the meters into centimeters, so it's 1 centimeter and 100 centimeters. You have to have all the units the same, otherwise this won't work. If you've done that, hopefully you found a percentage error of about 1%. Nice. If you don't remember all of these concepts off by heart, don't worry. through repetition over the next few months, you'll become more familiar with it. You'll become more familiar with it. Nice. So, I've actually got through that a lot quicker than I was expecting. So bear with me 1 second. I'm going to see if I can... There's something else that I'd like to talk about. Let us talk about anomalous results. Anomalous means unusual, essentially. Let's get that table back again. Where is my table? To find my table. Oh dear. Well, I don't know where my table is. Can you find the table from last lesson that you used to calculate the means and standard deviation? Have a look at column 400. And this is off the top of my head, my memory. Is there an unusual result there that you might not be expecting? There might be a couple. I think the blatant one is the 60, if I remember correctly. This is vastly different from all your other results. And it could be the fact that one of the controls weren't kept under control, or it could just be one of those freak things in science that sometimes happens, that you just get an unusual result. This could completely throw out your graph. So, for example, it could cause... Let's just get the rubber. Get rid of this. Imagine if your final point, you got such a crazy result that your graph, when you plotted, it ended up looking like this. Everything's in a nice straight line, lovely, nice trend, experiment's going well, and then suddenly you got a massive number and, oh dear, it even makes me not even draw in a straight line. Now, if you were trying to draw a line of best fit, it would probably be like something like that. But if you noticed you have the one anomalous result, which will be this one up here, this high one, and you removed it, suddenly your trend line of best fit looks much nicer. Now you can do that in your experiments as long as you acknowledge it. If you can acknowledge, hey, this point is crazy, it doesn't seem to match up with the rest of the experiment, identify it as anomalous, acknowledge it, don't ignore it, but acknowledge it, and then ignore it. So you'll write down, hey, this trend looked very nice apart from this one result, which seemed to be a bit anomalous. So we're going to acknowledge it, say, okay, I see you, little anomalous result, I know you exist, but you're messing up my experiment. So I'm going to ignore you. You can do that. And if you do notice them in your exam practical, be sure to mention about them. get bonus marks for it. Nice. What else do I want to talk about? Okay, I'll talk about one last thing today, because I bet listening to my husky voice on a screen with not many tangents is less entertaining than my usual lessons. So, upon the good grace of the cover lecturer, I'd like to leave you on this note. So this lesson will only be about 45-50 minutes, something like that. Final little definition. Primary data and secondary data. Imagine you were trying to find out the ages of people in your local hometown. You can go about this in a couple different ways. You can go about it in many different ways, but I'm going to give you two to get the idea of primary, secondary data across. If you went out in a high-vis jacket with a clipboard, little pen, some graphs, and you asked people on the street, what's their name and how old are you? You are collecting it personally. So that would be primary data. When you collect it personally, or you see the little colour change yourself in an experiment, that is primary data. Secondary data is when it's collected by someone else. So for example, if you went to the hospital and you got all the records of the people who've been in it, their name and their age, you did not personally collect that yourself. That was happened through a second party, and so that would be secondary data. If you looked up some data or answers on the internet, that would be secondary data. If you went out and tried to replicate and collect that data yourself, that would be the primary data. Now, I acknowledge you're all probably a bit faded. I'm exhausted. I'm absolutely exhausted. I hope this hasn't been too bad. And I hope that I'm back in college pretty soon. I've had my test today, so that might be a few days before I get the test results. If it comes back positive, you won't see me for another 10 days. So not this Wednesday, the following Wednesday. If it comes back negative, then I'm going to just assume that I picked up another random bug. There are other things going around. Corona's taking all the heat, is the biggest distraction, and all the flu and the gastrointestinal stuff is going undercover at the moment. If it comes back negative, as soon as my symptoms dissipate and I feel better, I'll come back to college. So, at a minimum, you won't see me until Friday. Got another lesson with you on Wednesday, I believe. It'll be somewhat similar to this. I'll do another video recording. Nice. Alright. Thanks, guys. I guess this is the end of the lesson, certainly. Now you will have to negotiate with whoever's monitoring or covering for me to whether you can go now, or if they'd like you to do something else. Jay, I think you're in the morning. You have to go to ALS. I I'm going to send Lauren an email with instructions with that. They need to set up a little more meeting with you. But unfortunately I can't show you to where that is because, well, I'm not in the college. Nice. Right. If any of you didn't understand any of the concepts of today, write them down and send me an email, because I want you to understand this. And if it means just re-explaining it in a different way, giving you more examples, I'll be very happy to do that. Okay, thanks guys. I'll see you when I see you.